Hello everyone, this is Eric from UNC Charlotte. I have been asked to talk about what computer science students should think about, what I wish computer science students knew, and how they can become better computer scientists. So this video is an attempt at answering some of these questions. This is not meant to be a long and extensive video that covers every possible situation. This is meant to be broad strokes. If you have questions or want clarifications, reach out and I'll do my best to answer. The most common question I get is, should a computer scientist be an excellent programmer? And how much should I know about programming? To answer these types of questions, I think of what that means from the perspective of an employer. I think of what level of computing competency I would expect from other majors, and I think of the level of competency of other experts in their own field. Fundamentally, programming is a basic tool in the toolbox of a computer scientist. So the question is similar to, should a woodworker know how to use an electric drill? Or should a doctor know how to use a stethoscope? If they didn't, I'd have a lot of questions. Maybe the doctor doesn't see patients because he does research, so they don't get to use a stethoscope on a daily basis. But surely, they know how to use it. There are woodworkers who do not use drills regularly. Maybe they work on acoustic musical instruments, and you wouldn't use a drill there. But surely they know how to use a drill. It's a basic skill when working with wood. Programming is literacy for computers. It is a basic skill for a computer scientist. Programming is to computer scientists what English is to lawyers. Do lawyers need to be the most eloquent? Do they need to know the most obscure words? No, they do not. But a lot of what they do on a daily basis will involve reading case files and opinions and writing legal arguments. Similarly, computer scientists need to be proficient in programming, because anything you'll do on a computer will involve programming at some level of abstraction. Maybe you'll program some user interface in JavaScript. Maybe you'll design test cases for an application. Maybe you'll write some drivers in C. Maybe you'll read code to find security flaws. Maybe you'll write script to automate deployment of a cloud infrastructure. Maybe you'll discuss the advantage of a tech stack over another. But one way or the other, you will need to be proficient at programming. How good of a programmer should a computer scientist be? It is going to be a core skill for you, but lots of people are going to learn programming as well. Mathematicians will learn to program. Mechanical engineers, civil engineers, electrical engineers, they will all learn how to program. Many high schoolers will learn to program. Many social scientists, business majors will learn to program. Physicists and chemists, they also learn to program. And most of them will convert to IT jobs after they graduate. So really the question is, what is it that you are bringing to the table and that makes hiring you more compelling than hiring them? For any technology that is in their core skills, a programmer should have the proficiency to recognize and solve typical problems within a short time. You should be able to develop simple applications in a matter of hours consistently. Things like take data from the standard source and extract simple statistic to generate a report back. Things like make a simple menu that enables you to add records in some dataset following some simple rules. Whatever simple applications are for that particular technology, this should take a couple of hours. For any technology that is not in their core skills, a programmer is expected to be able to learn them in a matter of a week or so, as long as that technology resembles something they already know. This is one of the things you are training to be able to achieve. I know Java, I never wrote Python, that's about 1 week. I know UI in the browser, I never wrote a native Android app, or something like I've always used Windows, I never learned Linux. These are all about 1 week of time. Now, in a week, you won't become the local expert, but all your knowledge should be transferable. You don't know what technology will be hot in 3 years, or which one your new team is going to use, and you will be expected to adapt as they come. How do we get to that level of proficiency? There is only one way to get there. It comes from practice. You have to practice intentionally and regularly. How do basketball players get good? They train. How do musicians get good? They practice. How do poets get good? They read and they write. So what's practice for a computer scientist? Well, it can be many different activities. The most obvious one is to pick a simple project, something that is at the skill level that you are right now, and do it. And do it by yourself. If it is at your skill level, you probably won't need access to much external material beside basic documentations. That will force you to write code. That will force you to debug. That will force you to work through simple problems. Over time, you will get better, and harder problems will become simpler to you. Learn a new technology. You've learned Java, so learn Python. You're interested in games, so learn a simple 2D graphics library. You want to do web things, so learn basic HTML, CSS, JavaScript. Learn technologies that are adjacent to what you already know, rather than something out of left field. It can take a bit of effort, but it's not hard. How do you do that? Start by following a tutorial and reading basic documentation. Follow along on your own the tutorials to see how things unfold. There are plenty of video tutorials, books, getting started documentation that will get you moving. Once you get the ball moving, you should probably be ready to do something on your own. Work toward a personal project, maybe something you have a passion for. But don't shoot for the moon. Be realistic. Replicate the tutorial project without referring to the tutorial. Convert something you have already done to that new technology. Do something that seems simple, and then work your way up. Finally, not all practice is necessarily you actively working on something. Sure, basketball players spend lots of time in the gym and on the court, but they also spend time reviewing their plays, reviewing other people's play, trying to understand the game better by discussing it with other people. You can do the same thing. You can review what other people have done. Looking at other people's code has become a lot easier since open source is so big now. Read some code. Make sure you understand what it does. You learn new styles and you will get used to analyzing code. Maybe, eventually, you'll contribute too. There are experts who wrote books or made videos about their industry, about their experience, about interviews, about how to run a large team, about how a particular technology came to be. They already did the hard work of compiling lots of knowledge and wisdom in an easily digestible format, often in a book, in a keynote speech, or on a blog. Read them, watch them, talk to them. That will expand how you think. Is programming the be-all and end-all of computer science? Absolutely not. There are a lot of deeper fields like real-time graphics, artificial intelligence, system performance, agile project management, scalable cloud systems, responsive user interfaces. But programming is a basic tool through which we interact with computers. Do all computer scientists need to be expert programmers? No, they do not, but they need proficiency to get anything done. How do they get that proficiency? By training on simple projects, by learning new techniques, by talking to one another. If you feel stuck, reach out to anyone with expertise. Reach out to faculty. We are here to help you.